Okay. Whether you're performing a designed experiment or an observational study, in either case, you need to have you need to collect a sample that's representative of your entire population. And the in order to do that, you have to use some kind of random sampling procedure. Okay, so in 1.3, we're going to talk about the most basic kind of random sampling. That's called simple random sampling, which is basically like drawing a name out of a hat. Okay, we'll talk about a slightly more sophisticated way to do simple random sampling. But that's the topic in 1.3. And then in 1.4, we're going to talk about other kinds of random sampling that you could use when you're collecting your samples. Okay. There's a lot we could get into with this topic. We're just going to scratch the surface here. Okay. So really, good practice for collecting representative samples is really determined by your field of study, right? I mean, it's going to be affected by your field of study pretty drastically. It's going to be affected by what it is that you're looking at and all sorts of stuff. But we will give sort of a basic overview of good random sampling techniques. If we don't use some form of random sampling, then we run the risk of obtaining samples that are not truly representative of the population. And I'm saying here that we'll discuss this a little more in 1.5. I'm actually going to skip section 1.5, so that's not true. I mean, you could read through 1.5 if you're interested. But section 1.5 just talks about bias in sampling and different ways that bias can seep into the samples that we collect. It's an interesting section, but it's just not something that I'm going to emphasize a lot in this course. Suffice it to say that you should do your best to use simple or to use some kind of random sampling technique. So simple random sampling. I'm just going to give you one example of doing this, but basically, simple random sampling is like drawing names out of a hat, and what I'm going to show you how to do is how to use a let's say, for example, and that we want to take a random sample of 3 of the firm's clients. Okay, now if you just choose 3 names, then that's possibly going to be a source of bias, unconscious to you, that cause you to choose certain clients over others, and so that would be bad, right? So in order to avoid that, we have to make it a random procedure somehow. So one way to do that, like I said, is to use a random number generator. You can just Google random number generator. Actually, so I've given you one here in the notes that you can use, but it doesn't matter to me which random number generator you use. Google actually has one. So I'm going to show you. If you just do a Google search for random number generator, then up pops this thing. And what we want to do, since we want to generate a random sample of 3 of the firm's clients, what we want to do is we will set our minimum at 1 and our maximum at 12, since there are 12 clients in this sample, right? So we want to choose 3 numbers between 1 and 12. So I click generate, then it's giving me a 5. Now, yours is likely to be different than mine. If you're following along and you're doing this with me in the home, then you probably got a different number, because this is a random process, so it should be a different number, right? But anyway, I'm just going to do this 3 times. So I hit generate again, I get a 9. And then one more time, I get a 10. So I got 5, 9, and 10. Your set of 3 numbers is probably different than mine. In fact, if you get the same 3 numbers as I did, then that's really pretty strange. That's pretty unusual. But I generated 5, 9, and 10. Now, if you happen to generate the same number twice or something, just skip it. See, like here, 10 happened again, right? So if my numbers had been 10, 7, 10, then I would have just skipped the second 10 and generated a new number, right? Anyway, but you just keep generating numbers until you get a unique set of numbers, right, where you don't get any repeats in your list. So 5, 9, and 10. Now I need to count which clients these are. So the 5th client, I'm going to go over 1, 2, 3, 4, 5. The 5th client was House of Hair. The 9th client, 5, 6, 7, 8, 9, was R&O Realty. And the 10th client was Simplex Forms. All right, so that's my random sample. And that's it. That's really all there is to it. Okay. As I said, you can use any random number generator you like. The book explains a way to do it using kind of a chart in the back of the book, which is, first of all, kind of an old-fashioned thing, right? Like they used charts and stuff. This is going to be like a common theme in this class, right? Like they used charts and stuff back in the day because they didn't have good like random number generators, right? But we have technology now that'll do this kind of thing more efficiently. Another reason that they use charts in the book is so that everyone gets the same answer. But it doesn't matter to me if you end up with the same answer. In fact, we should be ending up with different answers here. So anyway, but that's my random sample. So when you do the homework, right, you only have 2 problems, okay? But use a random number generator to get your samples. But I just think it's good practice for you, right, to use a random number generator to generate your samples. One last thing before I end this section, this is a really quick one, but one last thing is I mentioned that when you're generating your list, if you get a repeat, like if I had generated the list and my numbers were 10, 7, and 10, well, then I would have skipped over the second one and generated the next number 6, right? That's how I would have gotten my random sample. This first thing that I got would have been an example of sampling with replacement. So in sampling with replacement, a selected individual is placed back into the population and could be chosen a second or third or fourth time. But when we're performing simple random sampling, that's usually not what we do. Usually we do sampling without replacement, so that an individual who's selected is removed from a population and cannot be selected again to be in your sample. There will be some sampling with replacement that we do later on in the course, especially in chapter 5, when we're talking about probability, okay? So it will come up, but for the most part, when we're doing simple random sampling, it's sampling without replacement, okay? And that's all I have to say about that.